If I didn't give you like a retake sheet and you think you should have gotten one, let me know. Like I might have screwed that up and just missed yours or something. So I can look again if you believe I didn't. I think you should have got one. You think? All right. So we're gonna do indefinite integration. Definite and indefinite. We'll obviously get into both, but we're starting with indefinite. You could also think of it as an antiderivative. Sometimes they'll say they'll call it that. It's just the opposite. We're just going backwards. It's like we learned addition for the first quarter, basically, and then we're doing subtraction here. It's a little tougher than addition and subtraction, but that's the idea. Let's start with this. Let's say that the derivative is 2x. I want you to give me 3 different options for what f of x might have been. Try to give me 3 different possibilities for what f of x could have been. What? It's okay. It's okay. So I don't think one is too bad. I think the second and third are a little tougher. But the clue would be once you get the second one, you can make an infinite number. So one possibility is x squared, right? Because what's the derivative of x squared? It's 2x. Somebody give me another possibility.
X squared plus 42.
So wouldn't that also have the derivative of 2x? Because what's the derivative of the 42 part? 0. X squared minus a million. I'll just write 1,000 for short. Wouldn't that also have the derivative of 2x? So all of these would have that same derivative. So the way that's written in integration, so going backwards, you're going to write the integral of, so it's this is the integral sign. I think the integral signs when you look in school, do the integral sign? Maybe that's nice. But it's like it stands for summation, it's short for summation, so it's an S that's like stretched out. I think they're like fun to draw. Of 2x times dx. The dx you don't really know what it means yet. For now, we're just going to say there's a dx there, and when you integrate it, it goes away. We'll get to what it means, just not yet. Equals x squared plus c. So this is saying if I'm starting at 2x and working backwards, my original equation must have been x squared plus some constant. It could have been any constant. I don't know what it is. So that's like it could be the 42, it could be the 1,000. Because if you're going this way, what's the derivative of x squared? 2x. And what's the derivative of c? It's 0. So it like matches going backwards and forwards. I'm going to give you the rule in a second, but I just want you to try it. Let's say like integral of x to the third times dx. What's that? Integral of cosine of x times dx. What's that? Integral of e to the x times dx. What's that? So all those rules we did with the sine, the cos, the trig, the e, the ln stuff, that all still is in play. It's just backwards now. We're not to that part yet, I'll let you know. There will be like memorization quizzes again and that stuff. So I'm going to do these two first, because that's not really what we're doing now. It's just kind of like I'm seeing if you can come up with them. What would I take the derivative of to get to cosine? So this is sine plus c. I'll tell you this now, there will be a gateway on integrals at some point. Here you go. Okay. So there will be a gateway on integrals at some point, same way there was with derivatives. There'll be like 10 questions, you get 3 tries, same idea. Probably half of them will be indefinite integrals, and probably half will be definite. The indefinite needs the plus c. There's been, I'd say like 10% of people that do the gateway the first time forget the plus c, and then you just lost 50%, like just right there, because it's not completely correct, you know. So make sure that on the indefinites, the definite is where there's numbers here. We'll start plugging in a bunch of stuff. We're not there yet, but make sure on these you remember that plus c, because it basically would just eliminate one attempt to gateway right off the bat. What I take the derivative of to get to e to the x? The x, that plus c, right? How about this one? Am I good? Dustin? Good. So the rule, when we were doing derivatives, you brought the power down and multiplied, right? And then you reduced the power by 1. We're going to do that in reverse. We're going to add 1 to the power, and then multiply by the reciprocal of the power, of the new power. Reciprocal of the new power. So I'll detail that more in a second. But so if you just check this, what's 4? If I'm going backwards, taking the derivative, what's 4 times 1 4? 1, and then reduce the power by 1, you'd be at 1x to the third. Right? So try this one. Try. There goes 2x to the 5th. So if you remember the rule I just mentioned for 5 seconds, then great, use it. If not, try to figure out, try to work your way to it by taking the derivative over and over again of things, and just kind of trial and error. So if you're using the rule, what you would do is add 1 to the power, and then you multiply by the reciprocal of the new power. So I would put a 1/6 here and multiply by that 2 over 1. So you could put 2/6. Or you might have reduced it and said that's 1/3. Let me have that. One of those. Thanks. Yeah.
Did you write it as 2x to the 6th over 6th? Or x to the 6th over 3?
Yes. Okay. Yeah. Yep. So he was saying, can I write it like 2x to the 6 over 6? That's totally fine. The same thing. Other questions? Alright, so let's look at the rules then. So, if I'm integrating power rule, or integration, so if I'm integrating x to the n power, that's a really good integration sign. If you want to copy one, that's what we should have. I get irrationally excited about my integration signs. You add 1 to the power, so it's now n plus 1, and then you multiply by the reciprocal of the new power that you just created, not the old one, and then plus c. Then we can kind of check this too. If we take the derivative of this, we should end up back at x to the n. So what's n plus 1 times 1 over n plus 1? We'll just cancel, right? And then if I reduce the power by 1, what's 1 less than n plus 1? N. So we're right back where we started. If I had the integral of k times dx, where k is just a constant, like k is some number, what would I take the derivative of to get to k? Kx. And then plus c. technically you could, if you really want to, think about that as the same rule. Like this would be k times x to the 0 if you really want to make it that. So you add 1 to the power, which would make it x to the first. Multiply by the reciprocal of the power, which is still 1. You still kind of end up in the same spot. I don't think anyone really thinks about it like that, but if you know, if that helps you, that's cool. And that's it. Like, that's the rules. But the problems get a little, like, if you look at your sheet, the problems get a little tougher than what I just gave you. So I'm going to start doing just ones on your sheet. There's 20 on here, so there's still going to be plenty for you to practice after we do some. Let's look at number 1 together on your homework. The hard part about these is kind of rewriting and organizing, and then you're going to have fractions and negative exponents, and I mean, it's the same as everything else. Like the calculus isn't necessarily the hard part, it's all the algebra around it. So if I were doing this one, I got 2 steps to simplify before I can even start integrating. So first I'm going to distribute that 2. So I get 20x to the 7th minus 6 over x to the 4th. And there's not a quotient rule for integration. So you don't want variables on the bottom because there's not a rule for it. So we got to do 2 things here. We have to split this up into 2 fractions and then get rid of any negative exponents that we might have. We might run out of room here. We'll do what we can. So we've done this before. I'm going to flip it over for a second. What should that come out to? Like, just simplify that. What number do you get? 6, right? Would you agree that I'm allowed to split and rewrite each of those single terms on top? Isn't that just like a common denominator backwards? Like, simplify this. What do you get? 1 plus 2 plus 3, so it's still 6, right? So if I gave you this, you would use the, you got a common denominator, so you would throw that all on top. Well, we're going to do it like in reverse. We're going to kind of unpack the top into separate fractions. I'm just like proving to you that it's valid. So this is going to now become 20x to the 7th over x to the 4th minus 6 over x to the 4th. That's all times dx. Then I don't want variables in the bottom, so I'm going to simplify it by either like dividing and subtracting the exponents or bringing something up. So this would now be 20x to the 3rd, because I subtract 7 minus 4. And then this one, I'll bring the x to the 4th up, so 6x to the negative 4. And my integral sign has to stay there the whole time, because I haven't integrated yet. Like, have I even really changed the value of the original question? I haven't, right? I'm just like continually rewriting it to make it easier. Now I can use my rule. So questions on getting to this part, because the rule is easy, but getting there, and that's probably the hard part. I think I can go over again on these steps. So I have 1, so x to the 4th, and then you're going to multiply by the reciprocal, but there's already 20 there, so I'm doing 1/4 of that 20, which is 5. You can see how I get the 5. Same thing over here, add 1 to the power. This is easy to screw up. If I add 1, what do I get? Negative 3. So a lot of people put negative 5 there because you're like so used to derivatives. So add 1 is negative 3, and then you multiply by the reciprocal, which is a positive 1/3. So you have a positive 1/3 here times the negative 6, which is negative 2. Wait, whoa. Reciprocal is negative. Why did I say positive? Did I say positive?
You said positive.
The reciprocal is still negative. That's stupid. So that's plus. My fault. And then plus C. Questions anywhere in that?
Should we kick the x to the negative 3rd down? Negative x.
I'm not going to worry about that right now.
Alright.
The answers might, you know how to get there if you can. The AP test might, you know how to get there if you can.
Okay.
Fair enough. You guys want to try the second one?
Yes.
You do too. Then we'll get into like fractions and that fun stuff. checking, so I think it's good to start going. So I'm going to split it up first. I'm going to separate that fraction back out, like uncommon denominator it, and then rewrite each of those. So this would be 15x squared, because you're doing the 5 minus 3. This would be x to the negative second, right? Because 1 minus 3. And then this would be 10x to the negative third. And that's your rewrite. And I got room here, so I'm going to show, there's a step I kind of didn't ever show last time that could help you. You know how I was writing like the 1/4 up here and the 1/3 there, like kind of squeezing it in. It might be easier if you don't do that. So add 1 to the power is 3. Put your 15 there, and then multiply by the reciprocal of the new power. And I was kind of trying to squeeze it in. And I think as you get more used to these, you won't need this step. It's not going to hurt to do it. So same thing here. Add 1 to the power. There was already a negative 1 there. Multiply by the reciprocal of the new power. And then instead of just squeezing it in, I'm trying to simplify it up there, we're doing it in a little more organized fashion. Same thing here. Add 1 to the power. Multiply by the reciprocal of that new power. So negative 1/2. And then go back through and undo your multiplication there, just because it's a little more organized for you. So now it's 5x to the third plus 1x to the negative first plus 5x to the negative second plus. Is that right? Yeah. Questions on what I did on that one? Okay, so let's look at like 6. No, that's not even as hard as I want. Let's say, oh yeah, 6 is fine. 6 is good. 5. I'm at 5. I'll get there eventually. 5. We're doing 5. So the first thing I'll do here is rewrite this so there's no roots. We got a root there that I need to get outside of that. So what is this? X to what power? That's to the 1/5, right? Because you got the 1 inside and the 5 outside. You do it inside, 5 outside. The first thing I got here is this is 6 times 2x to the third times x to the 1/5 minus 5 over 5x to the third. Again, the calculus is not the hard part here. I'm going to distribute the 6 and the 5, or just the 6, the 5 doesn't really distribute. That was 4.
Left your suit and your phone and your baking soda.
Why do you know?
It's a long story, and I have some Reese
Yeah.
today.
Yes.
You gotta read for me, right? You gotta read for me? Alright, cool. Alright, so distribute here. So now I have 12x to the third, x to the 1/3 minus 30 over still 5x to the third. Yeah, alright, fine, yeah, I can't read my own writing. Yeah, sorry. Okay, and then this is a mess that I can clean up a little bit. So what do you do when you multiply the same base? What do you do with powers? Add them. Like x squared times x to the third would be x to the fifth, right? So you gotta add those up. You gotta get a common denominator to do it. So I'll give you a second to do that and not shut it out for everyone else. So 3 would be like 15 fifths, right? Plus 1 more fifth. So now this is 12x to the 16 fifths minus 30 over 5x to the third times dx. You with me? Now I gotta split those up, and so this fraction thing becomes kind of an issue here. I just realized I could have made this a lot easier. Oh yeah, I still can. That's okay. Alright, no, this is good. We're good. 12x to the 16 fifths over 5x to the third minus 30 over So we're going to simplify these now. So these numbers are locked in. These don't move up and down. You can reduce them if you can, but they just stay. So 12 fifths is 12 fifths. And when you're dividing, what do you do with the exponents? Subtract them. So how many, what's my exponent now? We just basically went back to 1/5, right? We added 15 fifths, and now we're subtracting 15 fifths. So now this is just x to the 1/5. Minus, so 30 over 5 is 6. That just stays. Like, you don't bring the 5 up. That's not the variable. And then this would be x to the negative third. And now it's finally like I don't have a fraction anymore. I don't have variables in the bottom, so now I can use my rules. There's still work to go, but that was work just to get there. I think I can re-explain or go over on how I'm getting there. So now I add 1 to the power. So now this will be x to the 6 fifths. I had 12 fifths already. I need to multiply by the reciprocal, which is 5/6. Same thing here, add 1 to the power is -2. I had a -6 already. I'm going to multiply by the reciprocal of -2, so -1/2. And the plus c should be there now because the integral is gone. And now with the little room I left you, we're simplifying. So 12 over 5 times 5 over 6, you can do this a couple ways. That's 60 over 30 if you go straight across. So that's 2. You could cross cancel, and then 12 over 6 is 2. Or you could just write 60 over 30. Like, that's a totally legitimate answer. What's -6 times -1/2? Positive 3, x to the -2nd, and then plus c. So that's the thing, I just put the x to the -2nd on the bottom. Not worried about that at this point with all the other stuff going on here. Questions on that one there? How's it seem? Yes. Try 4. distribute the 3, so I get negative 48x squared plus 21x to the 3/4. Then I'm separating, putting them both over 4. So this becomes negative 12x squared here. And then this, the 21 over 4, is just, you're just stuck with it, so just locked in there, 21 over 4, x to the 3/4. That's all times 2x. And now I can use the rules. I don't have any negative exponents. I don't have any fractions, I don't have any variables at the bottom. So that's the two, like, gotta clear those. Questions on getting to this point? Where'd you get this? Go to this again. Right. So now I use the rules. So I add 1 to the power 3. Reciprocal of that is 1/3, so 1/3 times the negative 12 gives me negative 4. Add 1 to the power here, so what's 3/4 plus 1? 7/4. And then multiply by 4/7, which if you're doing that up here, the 4's cross cancel and 21 over 7 is 3. So it actually ends up a lot more friendly than it looks like it would. Hopefully that's the answer. What do you got to that? Any questions I can help with right now? I'd expect to spend a couple days on this. Let's do this. Let's go up to 11 is your homework. Homework numbers 1 through 11. We just did 4 of them together, so it's not too bad. And then we'll check those, answer questions, and we'll give you time to practice the rest of them tomorrow. So we'll spend a couple days on it.